Good morning, student. Today is our lecture 7 of the same chapter light, and today we will cover the following topics. First, we will revise the concept of refractive index. Then we will do some question based on refractive index. Today's class is very important. So let us revise the concept of refractive index. First one is relative refractive index. That is refractive index of medium 1 with respect to medium 2. Like how we will write, this is N21. So here this is refractive index of medium 2 with respect to 1, or we can write refractive index of medium 2 with respect to 1. And as we know, it is a ratio of the speed in different medium. So it is V1 upon V2. Similarly, refractive index of medium 1 with respect to 2, or we can write it as refractive index of medium 1 with respect to 2 as V2 upon V1. So this is our relative refractive index. Now, if medium 1 becomes a vacuum or air, then that refractive index is called absolute refractive index, in which one medium is air or vacuum. Then we will write it as refractive index of medium is equal to speed of light in air or vacuum. It is denoted by C, and its value is 3 into 10 raised to the power 8 meter per second upon Vm, that is speed of light in that medium for which we are finding out the refractive index. If in any question it is given absolute refractive index or simply refractive index, like for example it is given refractive index of a glass is 1.33, that means that he is giving the value of absolute refractive index only. Now next thing is refractive index has no unit, because it is a ratio, so it is having no unit. Now next point under the same topic is optical density is not same as the mass density. Optical density is always different from the mass density. Mass density is that which we have studied in class 9. The density is mass per unit volume, and optical density is basically the ability of an medium to bend of a ray of light. Now, when in comparing two media, the one with larger refractive index is optically denser. The medium which is having larger refractive index, it is optically denser. Like diamond is having optical refractive index is 2.42, that is the highest, so it is optically denser with respect to the other medium. And the medium which is having a low refractive index is optically rarer. Next point is the speed of light is higher in rarer medium. Speed of light is higher in rarer medium than a denser medium. Next one, the speed of light is higher in rarer medium than a denser. This is the same point which I have repeated. Now, so this is same point. No need to write it again. Now next point is a ray of light traveling from rarer medium to a denser medium slows down and bends towards the normal, and when it travels from denser medium to a rarer medium, it speeds up and bends away from the normal. So these are the points which you have to keep in your mind while solving the numericals. Now, in second law of refraction or Snell's law, we have I have told you that refractive index of any medium, let us say refractive index of medium 1 with respect to 1 is given by sin I upon sin R. Now, what is this sin? This is basically the concept of trigonometric ratios, which you will study in this year only, class 10, in trigonometry chapter of mathematics. Basic idea I am giving you here, how to find out the value of sine of different angle. First, let us understand what is sine. Suppose this is a right angle triangle which is right angled at B, and this angle is A, this is B and C. Then sine A, sine of angle A is given by the ratio of perpendicular upon hypotenuse, means BC upon AC. This is a trigonometric ratio, one of the trigonometric ratios. Some other ratios are there which you will study in maths. Now, how to find out the value of sine for different angles? This also you will study in math. Although in numericals you will be provided with the values, but in case value is not given, you should know how to find out. So I am giving you the basic idea. Now here are some angles: 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. How to find out the values of these angles, sine of these angles? How to find out? First we will write counting from 0, 1, 2, 3, 4 and divide it by 4. And then we will take under root of the same. Like this we have written. First we will write 0, 1, 2, 3, 4. Then divide each number by 4 and take the under root of the same. Like this. After calculating the square root, we will get 0 upon 4 is 0. So under root of 0 is 0. Here it is, if we will solve 1 upon 4 under root, this will be 1 upon 2. Here we have written. Here first we will do the cancelling. 2 and 4, this will become 1 upon 2. So under root of 1 upon 2 is 1 upon root 2. Similarly here, the under root of 3 upon 4 is root 3 by 2. And here we will do first cancelling. This will become root of 1, that is 1. So here we can see the value of sine of any angle is increasing from 0 degree to 90 degree. These are the values which we will be using in the numericals. Now let us start our numericals. Now, question based on refractive index. So, these are some questions from your NCERT only. NCERT in-text question, page number 176. The first question is, the ray of light traveling in air enters obliquely into water. Does the light ray bend towards the normal or away from the normal? And why? We have to give the answer. Now let us understand this question with the diagram. Here I have drawn the diagram. This is air and this is water. The light is coming from air to water. This is the interface of two medium. And incident ray, this is the incident ray which enters obliquely. Because it is air is a rarer medium and it is a denser medium, so it will bend towards the normal. It is bending towards the normal. This is the refracted ray. Now, how we will write this answer? When ray of light travels from air to water obliquely, it bends towards the normal. This is because water is optically denser than air. So, on entering water, speed of light decreases. Just now we have revised some points. In those points we have written that speed of light decreases, and when it is going from rarer to denser medium, and the light bend towards the normal. So, this is the answer. Now, our next question is, light enters from air to glass having refractive index 1.5. Here the value of refractive index is given. So what is the speed of light in glass? Here light is entering from air to glass and refractive index is this. So this is basically the absolute refractive index. So we will write refractive index of glass as C upon speed of light in glass. This is the speed of light in glass and this is the speed of light in air or vacuum. This is the refractive index of glass. Now, Ng is given, C is given, we have to find out the value of Vg. Now, by using this formula, we can find out the value of Vg as 2 into 10 raised to the power 8 meter per second. So, this is our answer. Now, next question, find out from the table 4.3 the medium having highest optical density. So from the table, it is table 10.3, not, it is 10.3, not 4.3. By mistake I have written 4.3. It is 10.3. The medium having highest optical density. Also find out the medium with lowest optical density. So from the table we will see the refractive index. Refractive index of different in different medium is given in this table. You can refer for this table to your NCERT or previous class notes. Then the medium which is having the highest refractive index is the highest optical for that medium the optical density is highest. So the medium of highest optical density, from the table you can see diamond is having absolute refractive index as 2.42, so it is having a highest optical density. Similarly, the absolute refractive index is minimum for air, so it is having the lowest optical density. Now let us do the next question. Our next question is, you are given kerosene, turpentine and water. Kerosene and turpentine is one type of oil. In which of these does the light travel fastest? So we have to see the table 10.c and tell in which it is fastest. So what we will see? Yes, we will see the absolute refractive index of kerosene, turpentine and water like this. Here absolute refractive index of kerosene is 1.44 and for turpentine it is 1.47 and for water it is 1.33. So as we know the absolute refractive index of a medium is given by this formula, where c is the speed of light in air or vacuum, Vm is the speed of light in medium. So Nm and Vm are inversely related, hence light travels fastest in the medium whose refractive index is smallest. So that is water. This is the answer. Now let us do the next question. It is again a very important question. Very, very important question. Here the refractive index of diamond is given as 2.42. What is the meaning of this statement? Now what we will write, the refractive index or absolute refractive index of a diamond is 2.42. So this is the formula of absolute refractive index. It means, what does it mean? It means that the ratio of speed of light in air or vacuum, here the spelling is WM, vacuum to the speed of light in diamond is 2.42. And the next conclusion is that the refractive index of diamond is highest, as we see the table 10.3. So Vd means speed in the diamond is smallest, so speed of light of diamond is minimum. These are the two conclusions which can be drawn from this statement. Now whatever any other medium is given, along with its refractive index, the value of its refractive index, you can write these two as the conclusion of that statement. Now let us do some extra questions based on the same topic. Now first question is, now extra questions. Question number 1. If the angle of incidence for a light ray in the air is 45, the first medium is air, and angle of incidence is 45, and the angle of refraction in the glass is 30. The second medium is glass and the angle of refraction is 30. Now we have to find out the refractive index of glass with respect to air, that is refractive index of medium 2, that is glass with respect to air. The first medium is air, second medium is glass. Now let us understand this question with the help of a diagram. Here we have drawn the diagram. The medium 1 is air, and air is a rarer medium, and medium 2 is glass, which is a denser medium, so light will bend towards the normal. Here is incident ray, which is making 45-degree angle with normal, and here is the refracted ray, which is making 30-degree angle with the normal. So we have to recall the Snell's law. The second law of refraction, that is the Snell's law. According to that law, the refractive index of medium 2 with respect to 1. Here, refractive index of medium 2 with respect to 1. Here, medium 2 is glass and medium 1 is air. So, we will write it as this, Nga. Refractive index of glass with respect to air, or we can write it as this, as a ratio of sin I upon sin R. So, I is 45, so sin 45 upon sin 30. We have value of sin 45 as well as sin 30, which is given in the question as this. Here the values are given. So we will put these values here. After putting up the values, we will get Nga as root 2. This is the refractive index of glass with respect to air. This is our answer. Now let us do the next question. Now our next question is refractive index of a water with respect to air. So, and air is 1.33. It is given. And what is the value of refractive index of air with respect to water? Here water with respect to air, and we have to find out air with respect to water, that is reverse. Now for solving this, first we have to write down the given and recall this in the which we have done in the previous class. If we will multiply the refractive index of medium 2 with respect to 1 with the refractive index of medium 1 with respect to 2, the answer will be 1. So we will use this concept here. Here we can use by this, and using this concept and by transposition, we will get NaW as 1 upon NWA. Now after putting up the values, we will get refractive index of air with respect to water comes out to be 0.75. Here we will not write any unit because refractive index has no unit. Now let us do the next question. Our next question is the absolute refractive index of glass and water are 3 upon 2 and 4 upon 3 respectively. Absolute refractive index means one medium is air. And next statement is, if the speed of light in glass is given 2 into 10 raised to power 8 meter per second, then we have to calculate the speed of light in vacuum and water. Now what is given? First we have to write that. Absolute refractive index of means medium 1 is air. So refractive index of glass is given by C upon speed in glass, and refractive index of water is given by C upon speed in water, and their values are 3 upon 2 and 4 upon 3. And the speed in glass is given as 2 into 10 raised to the power 8 meter per second. These values are given. Now we have to solve the numerical. We know refractive index of glass is given by this formula. In this, we will write down the value of refractive index of glass as 3 upon 2. And by transposition, we can find out the value of C by putting up the other values. So, we have find out C as 3 into 10 raised to the power 8 meter per second. So, now the next formula is refractive index of water is C upon speed of light in water, and this is given as 4 upon 3. By transposition, we will get the speed in water as C upon its refractive index. Now we will put up the values and find out speed in water as 2.25 into 10 raised to the power 8 meter per second. So in this way we can solve this numerical. Now let us do the next question. The next question is the refractive index of water with respect to air. Again, it is an absolute refractive index, that is 4 upon 3. Similarly, the refractive index of glass with respect to air is 3 upon 2. This is also the absolute refractive index. Now, what is the refractive index of glass with respect to water? We have to find out the refractive index of glass with respect to water, that is refractive index of glass with respect to water we have to find out. Now let us proceed for this question. Now first we will write down what is given. The refractive index of water with respect to air is 4 upon 3. It is with respect to air, so it is an absolute refractive index. So its value is 4 upon 3. It is given by C upon VW, that is the speed of light in water. This is our equation 1. Similarly, we will write for refractive index of glass with respect to air. Glass with respect to air as C upon Vg, and its value is 3 upon 2. After putting up the value, this is our equation 2. Now to find refractive index of glass with respect to water, recall this formula in which the refractive index of medium 2 with respect to 1 is V1 upon V2. So here 2 is glass and 1 is water. So we will write refractive index of glass with respect to water as speed of light in water with respect to speed of light in glass. Now for solving this, we need to find out the value of VW and VG. Now let us see how to find out. Now from equation 1, 4 upon 3 is equal to C upon VW. By transposition, we can find out the value of VW, that is speed in water. The speed of light in water comes out to be 9 upon 4 into 10 raised to power 8 meter per second, which is 2. Now that is 2.25 into 10 raised to power 8 meter per second. So speed of light in water comes out to be this. Now this is our equation number 3. Now from equation 2 we will get this, and after putting up the values we will find out the speed of light in glass as 2 into 10 raised to power 8 meter per second. This we can find out by putting up the values here. This is our equation 4. Now by using equation 3 and 4, in this formula, that is refractive index of glass with respect to water is speed of light in water upon speed of light in glass. We have to recall this, and by using 3 and 4, when we will put up the values, we will get refractive index of glass with respect to water comes out to be 1.125 or 9 upon 8. It has no unit because it is a refractive index. So in this way we can find out the value of any refractive index. Now it's time for homework. Today's homework is very simple. You have to revise the topic of refractive index and note down the questions in your copy and revise the same questions which are done in this video. PDF copy will be provided to you. So you have to revise your classwork and revise the topic and practice the same.